share my slideshow, and I've done my best to socialize this with a wide range of people in advance and trim it down to something that is not overwhelming. I socialize this with my peers in the geological community. I socialized it with several pastors who weighed in with very thoughtful parts on human nature. And I socialized it with several veterans that I was just transporting that are quite knowledgeable about things, and they each in their way contributed very valuable points. So the first is I really want to mention my mentor and the person that's probably made the most formative impact on me is Dr. Ted Scambos. He was my TA at the University of Colorado. He went on to be the lead scientist at the National Snow and Ice Data Center. This is all the way back in the 90s. And I've corresponded with him off and on over the years because we just sort of kept touch of, as all those weird lessons that I learned in geology and he's as much as I can point to as a person that fulfilled that in a public scientific way. James Hansen is in there as well. He was a peer of my geology professors. And he's had an illustrious career, basically getting out there and publishing scientific data about Antarctica. I'm really much leveraging his contribution today in this presentation, because without him and his peers, I wouldn't have the information or the insight. I would be reduced to using the naval website, which, well, let's just say it's not online right now for some unusual reasons. And the key to this all hit high boil when the Larsen ice shelves broke up. And this is a timeline, a very terse timeline of what happened, that starting at about 1995, we kind of went to sleep after the 80s. And we wanted these ideas you always hold in this twilight, because my professors were open about their theories of breakdown of Antarctica. And this was a very real example of this. This is out on the Antarctic Peninsula, quite a ways from the mainland mass of Antarctica. But starting in roughly 1995 up till about 2022, the Larsen ice shelf lost the cumulative 4,000 cubic square kilometers of ice. It just went away. And this was a real life example of how fast large ice masses that have their grounding in the ocean can move. This kind of leaves out the melt pools that were forming on the surface, the increased snowfall that we saw, and many other details. But I just hold this up as the example that from the start, we saw some beginning of the big changes to that when it was gone was roughly 7 years. Things can move very fast. The basic sequence that we were taught in the 80s and have been following ever since is you get an increase of moisture over the poles. This acts like a blanket over the poles because moisture blocks the radiation of heat into space. You can kind of see that the Earth has two big air conditioners on the poles, and it soaks up a lot of heat in the mid-latitudes. If you put a blanket over or impair your air conditioner, you get hot because you're not radiating the heat out. And that causes an acceleration. The second is this moisture accumulates a lot of snow on the ice sheet and ice shelves. Now, snow for us in the mountains means your glaciers get bigger. But in Antarctica, it has the effect of warming up the ice because snow is an insulating blanket. And the ice temperature is a critical detail because in the heat of the summer, all you need is 2 weeks of above freezing condition, and that snow melts and forms melt pools. If that's on really cold ice, it does nothing. If it's on warm ice, it'll go down the cracks and it will begin to force the ice apart. And that's what we saw in the Larsen B. It was like 5 years of melt pools until the melt pools they all went away and the ice just crumbled like dominoes. So this is the rough sequence that the large-scale ice can break up. And this is kind of what we look for. Is what I'm going to show you is what stage are we in the sequence? Because there was an article about the melt pools, but it mysteriously went poof on the internet, and I couldn't get a hold of it. And there are people in the oil industry that are watching this stuff very carefully because they know their business depends on it. Uh, the this has been a long running discussion because I'm being faithful to the rock group, the number 3, the geologists. Almost everything published out there in the media is of the air group. These are scientists, they tend to be physicists and chemists, and they have a wealth of over 300-year record of temperatures that were recorded on land. And the idea is if you can develop a model of the atmosphere, how it works, that can explain the temperatures in the past, it's good about predicting in the future. You're just changing the variable about how much CO2 is in the atmosphere. Unfortunately, they don't have a lot of experience outside of alpine glaciers. Again, the Earth is a much more complicated system than just the atmosphere. The water group is the oceanographers, and they too have a very long history of all of the expeditions, and starting in about 17 with the George Vancouver, he was logging the temperature of the ocean as he crossed it. So we don't have a great record, but we do have some record. And particular in the last, since the 1950s, the military and other groups have been studying how the ocean and the ice caps have been changing. And they tell a different story because water is about 1,000 times denser than air per cubic meter and about 4,000 times different in heat mass. So a little change in the ocean is you can literally see the entire atmosphere is like 30 feet of water all around the world. It's actually less than that. And so the oceanographers have been talking about a very different story. And I noticed that they published a story about ocean current acceleration, and it was immediately discredited by several other studies that were junk studies, but they were trying to discredit it, and the whole thing disappeared. Again, the more sensitive you get to something meaningful, the more the oil industry is going to clamp down on it. Now, it's the rock group, which we had, one of my finals was famously a chunk of fossilized wood from Baffin Island on a table saying, explain this. We have never got along well with the physics or the chemists or the people who do statistical analysis because we're trying to explain how you had a large forest on Baffin Island 20 million years ago. And particularly these little pores on plants that allow gases to circulate. That's how plants get carbon dioxide into them. And they only have as many pores as they need to get us enough. And so if you increase the amount of carbon dioxide, you should get fewer soma. And so the soma studies, that was the main point of the geologist saying, your math of the air group about how you explain previous geologic ages makes no sense. The soma don't support it. So they were saying, you got your model wrong. Now, this has been a running discussion now for 43, 44 years. And I have to hand it to my geology peers. It sure looks like they were right. And that's kind of the heart and soul of this presentation. And it really gets into a facet of human nature to say when you're really facing a big change, or, my geology is saying you got 7 years before the Antarctica goes in the water. The group, I know this from my New Orleans group, the group that says we will adapt or choose, we have already left the New Orleans area. There's a group that will struggle because they love the culture of New Orleans. And there's a group that has an identity to say, my identity is there. I'm only going to leave when I'm forced to leave. And so I really caution to say, the whole idea is we had to go tell everybody so we could get a change in society. It is a now reality to say, well, it's okay if people want to stay or they struggle or we adapt. Because that's really a facet of human nature. And I don't mean to punish people for being the way they are. It's much more to say, how can we adapt intelligently to these things? So I'm going to start with the data. And I was originally going to present a massive heat wave in August. And there were 5 other heat waves after that one that were really kind of alarming. And then as I was preparing this on Monday, I noticed, oh, that looks like another heat wave forming. And I recorded this on Thursday, but it had already been going on for several days. Now, the temperature alone in Antarctica, because it is so cold, is not that concerning. This recorded at its core is around 30, halfway between 24 and 30. That's 28 degrees Celsius. Now, this is an average between the day and the night, so that the high temperature is like 40 degrees Celsius higher, and the low temperature is like 20. But what we've noticed is we've had heat waves ever since this tool from the University of Maine really got going. And they covered, the heat waves were shorter in duration, and they were smaller. And so we've watched how the size of the heat waves have grown, and their duration has really gotten longer. And this is a very good example. This is roughly half of Antarctica. And if you look at it in the moisture, this is in a standard deviation. And again, this is going to be a hard term, but you can just simply say that a standard deviation 1 is like a chance of 1 out of 10. You can add a 0. And so the standard deviation is how many zeros are you going to add to say how improbable it is. So a standard deviation of 6 means you have 6 zeros. What the truth of this is the moisture. This is the anomaly of water getting on the continent, based on what what they've recorded over this 21-year period between 1979 and 2000. That's their baseline. And this is all done by satellites orbiting the Earth, so they're very, very sensitive accuracies. And essentially, if you double or triple the amount of water on Antarctica, it breaks all the models. And that's what you see when the moisture is starting to come on the continent. It just pegs the scale. It no longer means that the atmospheric model that the air people put together to explain how the weather would interact with Antarctica, it just doesn't make any sense anymore. If you look at the upper atmosphere, this is the 500 millibar level, it gives you a sense whether the air mass is just local on the ground or it's a more sustained. And again, this is in standard deviations, and you're hitting in the 4 to 5 range. It's basically a mass of warm air said, I'm going to move on to Antarctica. And as you can see by the cold air spread off of Antarctica, which is exactly if you put too much water in a tub and the drain gets overwhelmed, it will stop swirling, it will stop draining, and it will just sort of gently stir. This is exactly what the astrophysicists were part of the geology group, and this is saying they were these diagrams, and they say they did it like the rings of Saturn. And we all looked at that and say the Earth is different. And I'm here to testify they nailed this diagram. So here it is on Friday, and well, let's just say I gave up the whole idea of incorporating the August results. This one's bigger. Now, this is later in the season. This is when they start to damp down and get smaller in size. Not in this case. Again, it still has a massive amount of water, and as you can see, it's over a very large region. I mean, that's a large enough region that you see it in space in a reduction of heat radiating into space. Again, this persists, this large arch. We get to yesterday, and I said, it should have broken up by now. It's been running since Monday. And it said, lo and behold, no, there it is. That's a very high percentage of Antarctica, and that's the trend. So that you got small, infrequent storms, they get bigger, they get more frequent until literally you're just going to cover Antarctica with warm air and this moist. And if you, the next slide is the moisture, and you see another warm front is coming from this side. This is the Thwaites glacier. This is West Antarctica. This is East Antarctica. In almost all of the published climate models, East Antarctica is considered secure, while West Antarctica is vulnerable. Geologists said it doesn't work that way. If you get water anywhere on the continent, and East Antarctica is just as vulnerable as West Antarctica. Because once you put enough water in the air, the whole continent gets warm. And the arch, you see this arch, and the cold airs up here. I saw there was a weird pattern in this is South America, this is Africa, this is Australia. Australia had a bizarre heat wave and cold front. And then I started noticing the North Pole has been doing this weird thing for several weeks. And I said, well, maybe I should report on that, because if it was just the South Pole, we say it's some sort of oscillation. But in this case, the North Pole is really hot too. And it's not as hot, but you just see the area. I mean, this is the Arctic Circle. As a percentage of the Arctic, it's about the same. I haven't seen a single report on this. If you look at this is today's, and I have wondered if I just should make this a surprise and show you how to use the tool. I can do that if you'd like. But there it is again, and we hit, we're solidly in the 30 Celsius range. This is the water in the Arctic. Oh, sorry, I got these slides mixed up. This is Saturday, and it also did a 6 sigma in the Arctic. So you aren't just getting record events in the Antarctica, you're getting them in the Arctic at the same time, which if you get them on both ends, it means it's a global weather energy pattern, meaning it's got enough energy to send it to both poles at the same time. This is Saturday's reading. Again, it was really hot. This is the moisture reading of Sunday. Again, it's moved over here. This is a very vulnerable area here. This is the Avery ice shelf here. This upper corner is also vulnerable. And wherever you see a lot of moisture, there's snow on the ground. And so the snow, which used to be quite thin, maybe, couple feet. I mean, all the people that I know that walked around these ice sheets in Antarctica say it's pretty easy trudging. You don't sink in very far. Now you're talking about snow drifts from 3 to 6 feet. It has a dramatic effect of insulating the ice. Again, the same arch. It's moved around a little bit, but it's still hitting, again, a two standard deviation is what you should see most of the time. That's 95% of all occurrences. Anything above 3, and we're hitting 4s and 5s and 6s in this. This is today's at the Arctic. It's just hot. And now I'm just going to make you the association. If you see these record temperatures where they used to be kind of dry, now they're wet. It's just getting simpler and simpler. And again, it hits 6 sigma here. It's a smaller thing, but it's a projection right across the pole. So I'm going to shift gears here because I know that's a lot to soak in. And I kept the rest of this presentation relatively light because that by itself, that data, to anybody in the scientific realm, they know that the atmospheric model doesn't matter anymore. You've blown it out. The oceanography model, they've been reporting about how the North Pacific responded this year. The North Pacific was 5 degrees Celsius warmer than normal. And that is an insane amount of energy. So we're really talking about something that's coming really fast and really intense, because I can look at the growth from just August, and I saw these storms in both the Arctic and the Antarctic. I've been following this ever since I got out of school, and I've never seen that kind of acceleration, just like you hit the sharp end of the curve. So I'm going to shift gears here and talk about the other things that are really going at a sharp curve. This is the California Independent System Operator fuel mix. And I just looked at that and said, oh, that's going to cheer me up because the bright yellow thing in the middle is the solar. The purple color is the batteries, and the red is what the imported energy from stations outside of the California operations. And this is one of the best evidence I can see. If you've been following this for years, we are going to electrify really fast. And it's not an idea about what we're going to do, it's a reality. And that is going to be its own shakeup. But I say that's a shakeup I like to see. There is a revolution. This came out a little blurrier than I hoped it would, but there's a revolution in what I call saltwater aquaculture. And its main thing is they're looking to produce shrimp and fish and sea plants. This is an example from Africa of all places, because that's where a lot of people have been doing it. And I just want to explore the idea that no matter how the world changes, as the sea levels rises, and you're talking, the geologists were freely talking about rates of sea level rise in the half a foot to foot range per year. They were very succinct about what happens when these ice sheets hit the water. But I also say there's plenty of food you can grow in salt water. And there's plenty of places around the world that are not currently used for croplands that would be ideal croplands if you just flooded them with a bit of salt water. Again, there's a method to do it, but I'm not a doomsayer to say there's going to be a shortage of food. Matter of fact, in a weird way, saltwater aquaculture is more productive than marginal lands. So I looked at the people of like Iraq as this very low-lying valley, and they're going to get flooded out. They're going to switch from what they used to do to what makes sense of saltwater aquaculture. And so I'm not saying this is necessarily a bad thing, but it is a massive change happening very fast. This is a fact about the United States, that all these changes mean that the United States gets less precipitation overall. And so where there used to be small droughts here, it's now the whole continent. And you're going to have to think about more effective water policies that go with this. But now that's a farming revolution. And if I had my older daughter here, who's a biologist and a botanist, she would go at length for all the things that grow in the desert that you can eat. So I'm not a doomsayer here. If anything, we're looking at a more conscientious and more efficient farming system, because they can't just spray water around like it's nothing. They can't spray fertilizer around like it's nothing. Again, this is a massive change, but if you talk to almost every agricultural department in the United States, they're way ahead on this. So where I've shown this image to a lot of people and they were not aware of it, if you talk to people in the agricultural data, they're planning on it. It's kind of a weird thing that when in massive change, you get this delay of information. If you look at, I was looking for something on the insurance industry. Now, this is a part of a conversation I've been for a long time. And I love this picture of a house because it's going to get obliterated. You look at Miami, you look at a whole bunch of cities on the coast, they are facing obliteration. And it's the people that probably fear this the most are the people that live on the coast that own these nice houses. Because you look it up at Connecticut down all along the eastern seaboard, you got to be relatively rich to live on the coast. Now, for average, more moderate people, they will move inland. Again, there are lots of ways that housing is changing right now, that they're lowering the costs, they're speeding up the efficiency that you can build things. A lot of this boils down to, I noticed Minneapolis. They basically said, if you want to build it, we've got to, the only way to lower costs is if you just build it. And so you're going to see there's a whole presentation all by itself about how housing is going to change in the insurance industry. Because once the first ice shelf crumbles in Antarctica, the insurance industry is going to figure out their model is busted. They're going to use the geology model. And you're not going to be able to get insurance unless you're over, what they consider something secure, probably 50 feet of elevation or more. because a hurricane can get up quite a ways. And so if you see this in advance and you see this is credible, it's you can sell to a denier right now. There's no real loss. I know real estate in Miami is down by quite a bit, but it's a good time to just simply say, this isn't going to work out the way you want it to. But again, you kind of have to be rich to think that way anyway. I mean, change is just, we're at the period where change has been relatively slow, and it's not going to be slow anymore. So I just leave it to this point to say, what can we do? And this is where the heart and soul of all these conversations I had really boil down to these central things. Unless we're calm, we cannot really think rationally. And so it's a double win. Not only do you say all these external things that could really irritate me, bother me, unless you're in a house right on the coast or you're facing any of these major problems, it's just be calm. Because personally, people are going to come to the Seattle area from these other places, and that's its own thing. And the second is to be healthy, because if we're healthy physically, mentally, emotionally, we can be of assistance. We can play a functional role in this. When I got out of geology in the 80s, everybody was depressed for a decade. We didn't want this to happen. Now I recognize that there's a healthier way to this. Just be calm and say, I don't live on the coast. Be healthy. I drive passengers around that go into from medical appointments. And the third is doing what we're doing right now, is to be part of a community. The fourth is to be aware of what's going on. Keep learning, because I could have a whole hour presentation on what's going on in agriculture, what's going on in housing, what's going on in energy. Each of these pieces of our future. If you're part of a community, everybody sort of says, well, I'm going to tackle this focus, I'm going to tackle this focus, I'm going to tackle this focus. And the last is to consider, how do we want to fit into this? Where do we want to be involved? Where are our talents? What is it really we're adapted to? What, interests us? Because even just being a supportive member in this and doing community is a lot of things. I'm not asking everybody to do everything. And if I know these agriculture departments, that's really what's happening. If you look at housing, you're looking at these bold people. Weirdly enough, they're in Florida. They're talking about these type of housing that are hurricane and tornado resistant, and they're mobile. They just simply will just move the city. And everything about energy. Again, Trumpty Dumpty is going to last a year until the midterms, or maybe 3 years, but it isn't going to stop this revolution of electrifying around the world. And I saw an article about India. They're going gangbusters with solar. They're going gangbusters with electric vehicles. Again, massive change, but a good change.